Thanks for waiting for us to get started here. I'm sitting here next to Jessica Dean. Got her own camera on her as well. Really excited to have everybody here today. Jessica has prepared a really fantastic presentation we've been looking over for the last few days. And really, this is something that's been developing probably over the last year almost. I mean, I feel like I've seen kind of evolutions of this, and now it's a much more refined and impressive and awesome. So very excited to have that. Why don't you go ahead and introduce yourself, and I'll turn off my mic and you turn on your mic, and I think it'll work best that way.
Okay, let me make sure that unmute myself.
Perfect.
Perfect transition. Look at this teamwork. Yeah, no, it really has been about a year. It's actually kind of cool because we met at a Swamp Up back in May of last year.
Yeah, which is coming up again.
I know, we're both gonna be there again.
Yeah.
Imagine that. Swamp Up, JFrog. So I am Jessica Dean. A little bit about me, my background. I am super into Linux, open source, containers, IT operations, so not primarily a developer background. And I don't often throw DevOps into that particular bullet point because I kind of feel like all four of those areas kind of imply DevOps. And we'll talk about that. We'll talk about how DevOps is really just kind of the world that we all live in at this point. Some non-technical things about me. I am super into CrossFit and training. So I try to drop into a CrossFit gym wherever I am, or at the very least a gym. And I'm usually doing crazy stuff that then people end up looking at me funny for. I'm also a huge Disney and Star Wars fan. And I don't just say that lightly. I actually have Han Solo's blaster tattooed on me, Luke Skywalker's hilt. I have a fandom crossover theme with some Star Wars quotes and Gallifreyan from Doctor Who.
Plus, it used to be that you had to compete between Disney and Star Wars, and now you can just love them together.
I can, and I can love Marvel now together. I no longer have to cheat on my geeky loves. And then one more thing that goes back to tech is I'm also a member of what we call the League of Extraordinary Cloud DevOps Advocates. So what that is we are a team of cloud developer advocates, or DevOps focused, at Microsoft, and our job is to focus specifically on the DevOps culture and to kind of educate developers and IT operations on good and best, not good, best DevOps practices. What I love most about our team is we are actually really well balanced. We have Abel and Damien on the left there, myself and Steven on the right. The right side tends to have more of an operations background. The left, including our fearless leader, Donovan Brown, has more of a developer background. So we really kind of get to embody that developer and operations DevOps kind of culture we'll talk about today. And you can reach out to us by hashtagging on Twitter, LOECDA. That's actually like our bat signal. We'll get a notification in our Microsoft Teams room anytime that hashtag is used. And if you have a question or comment or want to talk about Star Wars, we'll all come to your rescue. A little bit more is, while our team is awesome, we are only a small part of a larger cloud developer advocacy group at Microsoft. There's about 60 of us worldwide, and we have all different focuses. So from Linux, open source, ASP.NET, DevOps, machine learning, AI, IoT. We have some really amazingly talented individuals on our team who, if you have, again, any kind of issue, hashtag Azure Avengers or follow us at Azure Advocates, and you'll get 60 people coming to your rescue to answer your question.
Yeah, I've pinged the team a few times on Twitter and found very responsive.
Yeah, again, 60 people around the world. We have every time zone covered. It's pretty awesome. And now let's talk also about CodeFresh.
Yeah, so let's swap mics again so we do the proper 3, 2, 1.
Hold on.
Oh, no.
Otherwise, we're going to get this inception.
So I'll tell you what CodeFresh is. It's okay. So CodeFresh, basically, what we found is that as people are adopting Kubernetes, that there are so many things they need to figure out: how to build the images and store the images, how to deploy them, how to do the change management. And we found that it would be really, really effective to build a platform that basically brought all these elements into one place. And so CodeFresh is really the workhorse engine of your engineering team and your DevOps team, where it's going to build your images, it's going to store them for you, it's going to connect all of your testing. It has built-in steps for working with Helm, etc. Really, it's four main components. We have these Kubernetes CI/CD pipelines. That means they're pipelines that are designed to get code onto Kubernetes and get it deployed. There are self-service environments, so you can actually spin up instances of your application on demand, which you'll actually see today. So you can basically get your full application suite, your full microservices architecture running. We have release management through Helm, and then we have Docker and Helm registries built in. So that's what CodeFresh is. So basically the goal is you want to commit code, you want to go through a build process, you want to build your chart, you want to run integration tests, performance tests, security tests, really functional tests that take into account the microservice architecture and test the infrastructure code, right? Because with Helm and Docker, you can actually define the code for your infrastructure. So let's test that, and then let's push it all up and deploy it into production. That's what CodeFresh is, and that's the intro for CodeFresh.
And we'll get to see actually just how awesome that is today. I work with a lot of different CI/CD tools, but one of the things that CodeFresh has that no other tool has is really the ability to visualize your deployments with your Kubernetes clusters and with your Helm deployments. You actually have a built-in dash that's really powerful and insightful. So well show that today.
I'm going to put that on a t-shirt, Jessica.
Yeah, I'll wear it because I'm like, look, I'm even wearing my CodeFresh container shirt. I plan ahead. So let's go ahead and kind of dive into it. I know we only have an hour and there's a lot to cover. So first off, we're going to go through a DevOps overview, and that's really essential so we can understand more about container orchestration and how it plays into DevOps. Then we'll talk about Kubernetes, we'll talk about Helm, and then we'll go into a live demo. So first off, let's go ahead and talk about IT. And when I say IT, I mean the developer world and the operations world. We're changing, and we're changing rapidly. This was a study that was done a few years ago by Gartner, and we are going digital. If not, some of us already have gone digital. They estimated in their study that by 2020, 1 million devices per hour would be coming online. 1 million. That's a lot of devices. The average age of an S&P 500 corporation by that same year would be 12 years of age. Compare that to the 1960s, where it was 60 years of age. And then I always save the last statistic for last, not only because it is last, but because I find this to be actually the most shocking. They estimate that 60% of computing would be done in the public cloud by 2025. But that's only about 7 years away. And we're already seeing such a shift to the cloud. We're seeing workloads being run either in hybrid scenarios, full cloud scenarios, or on-prem companies already pushing for, where's the cloud? How do I get to the cloud? You have your grandmother talking about the cloud, but when she does, it's the cloud. There's air quotes. I told this story when I was in Orlando. I was having breakfast at this place called Angelina's, and there happened to be another mother and daughter who was sitting next to me that spoke English, and it was refreshing. So she asked what I do and what I was in Paris for. This was a few weeks ago. And I told her I worked for Microsoft, and I essentially am a public speaker. And so she said, she looks at me immediately and says, "Do you know where the cloud is?" I said, I do know where the cloud is. Actually, I talk about the cloud constantly.
It's where I work. I work
in the cloud.
Yeah.
Well, her immediate reply when I told her I knew where it was, "I'm going to tell everyone I met the cloud. And the cloud's name is Jessica." And I thought that was hilarious. But it's true, right? We have to start thinking about the cloud. And so from a Microsoft perspective, we wanted to take a poll from both developers and operations. So if you're on the dev side, tell me if any of these sound familiar. I need to create applications at a competitive rate without worrying about IT. New applications run smoothly on my machine, but it malfunctions as soon as it hits your server, Mr. or Mrs. IT person, which I would get that all the time. It's, well, it works fine on my machine. What's wrong with your server? And then the final is my productivity and application innovation becomes suspended when I have to wait on IT. So I become the bottleneck for the developer. But then on the flip side, because we have to give love also to IT, what we end up hearing is that I need to manage servers and maintain compliance without any kind of disruption. So I can't just give you, Mr. and Mrs. Developer, access to my servers. Also, I'm unsure of how to integrate unfamiliar applications, and I need to work with you as the developer. I'm unable to focus on both server protection and application compliance. There's really kind of this gap that we have to figure out how to meet between developers and operations. And that's really kind of where the conversation for DevOps starts. In this particular slide, IT stress points. It's not just IT or operations, it's IT and developers. We all have to worry about security threats. We all have to worry about efficiency. And we all have to support this rapid innovation we've been talking about. So that's why the cloud is important. It's the new way to think about your data center. The old traditional model was dedicated infrastructure for each application. The hardware you built, or the hardware you used, was purpose-built. Your infrastructure and operations teams were distinct and separated, especially from your developers. And the processes and configurations you had were customized for each project, but it's not really scalable. So now with the cloud model, you have loosely coupled apps and microservices compared to giant monolithic applications that fell under the traditional model. You now have industry standard hardware. Your teams that you have for infrastructure operations development are service-focused DevOps teams. And your processes and configurations now are standardized across the board. So each project is going to be able to be repeatable and immutable. And that's really why the cloud model is important. So that's where the conversation for DevOps starts. We start with people, as we've talked about, developers and IT, and then we have to go into process and products. And I love the quote, actually, my boss, little Dono dude down there, who my boss is a South Park character. But I love this quote. And he actually spent 30 days coming up with this quote so that every single word here is something that he could stand behind and something that every single one of his team members can stand behind. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. And I'm very specific when I use the word products as opposed to tools, because again, a tool, like if you think of it, a hammer, a nail, some 4x4s, and you're trying to build a house, the tools individually aren't going to build the house. But if you, again, have the union of the right people, a process and a plan in mind, and then you use these products to your benefit, you're able to create a really beautiful end result. And more importantly, you're able to produce something valuable to whomever your audience is. So that's really where DevOps comes in, and that's why it's important. So we've talked about people. Now we're going to move right on into process. The process is kind of 4 parts. You have a plan where you have to know where you're going, map out what your goal is for this particular product release or application release. And you move right into your development stage, right? You have your develop and test. And that's where we would call that more of CI or continuous integration if you're using DevOps practice words. You heard Dan mention earlier, CodeFresh is a CI/CD tool. But often, since we in tech use so many acronyms that becomes alphabet soup, we forget to really define what that means. Continuous integration is your build. That's continuously building with some automation. And after you have your build with your unit tests and your code and everything in your version control and source control, you take an artifact that's been tested, that's been ready for release to your dev, your QA, or production environments, and then you hand that off to the 3rd step, to the release stage. But your release is also your continuous deployment or your CD step. And so we'll walk through that when we get to the demo. The 4th step is also really essential, is what products can we use that will give us insights into how successful our deployment was. How can we monitor and learn from what went right and what went wrong, and be able to repeat that in the next iteration, the next release. So again, you heard me use some of these words. You have continuous integration and continuous deployment for your build and release. Infrastructure as code is also a new one, specifically to IT. That's where you're able to take your infrastructure, keep it in source control, but be able to stand it up as part of your code, right? That's why Dan mentioned that Helm and Kubernetes really gives us that ability by standing up our services, standing up our networking, standing up our infrastructure that we previously, back when I first started, I would have to set up a virtual machine and configure everything manually. Now I can deploy the app, the infrastructure, everything simultaneously, and it's all in source control. So in the event of a failure, I can roll back to something previously validated, but the idea is in the build stage, it's already tested. I don't have to worry about it potentially failing in production.
Yeah, and I would add that this is really kind of the dream of, like, the holy grail of Kubernetes and Docker and containers. It's all that this infrastructure is essentially ephemeral, that we're not setting up environments, we're defining environments, and we're allowing the scheduler to set it up for us. And this also goes back to testing your code is one thing, and testing your infrastructure is the next layer down. And it's actually super critical, because most of us think about introducing errors and regressions as code things, but in fact, most real downtime that happens when AWS went down last year and people couldn't turn off their ovens anymore, sad state of affairs, it was because of a configuration change that wasn't tested. So making it so that we can infrastructure as code means we can test it as code.
Yep.
Is incredibly powerful.
We can have the same unit tests that developers have been using with their code. We tie that into our architecture, which, again, coming from an IT operations background, that wasn't something that was native. But now having these tools that make it simple, we don't have to think about it a second time. And then other things, load testing, auto scale, feature flags. There's so many different practices, but some of these keywords you'll see how container orchestration plays on, and specifically Kubernetes and Helm. So I have a funny video. This was a video I recorded at KubeCon, actually last year in Austin. Dan was there too. And the funny thing, it's very basic container orchestration. It's supposed to help understand what container orchestration is from a very, very high level. Before we actually finished wrapping, a woman had come by, and she was watching us as we were finishing our last take. She actually tells us that she had been at KubeCon all week. She was one of the volunteers, but she didn't actually understand what was going on. She's not technical. And after watching the video, she actually said, I think I finally get it. When something fails, it's still up. We're like, yeah, from a very high level, that's the entire purpose. That's what we want you to take away. So I'll go ahead and play it. It's less than 2 minutes.
Hi, my name is Jessica Dean, and I'm a cloud developer advocate at Microsoft here at KubeCon.
And I am Eric St. Martin. I am also a cloud developer advocate at Microsoft, but I am not at KubeCon.
Then how are you right next to me?
You're not at KubeCon either.
What?
We've got a green screen and an amazing producer.
This is some really good virtualization.
So
What are we doing today?
we are going to do a live demonstration of container orchestration with something like Kubernetes.
I'm really excited. Let's get started.
Over here, we have our image repository filled with containers that we would like to deploy. Jessica is going to be our scheduler.
Apparently.
So here's our first container, and go. That's Docker file. Okay, we fixed the Docker file, and we're going to deploy this one.
Yay!
Sweet.
And we can have multiple schedulers,
So
especially for the sake of time.
here we go. Containers, lots of containers.
So let's make sure that we also get our bin packing in order here.
We don't want any leftover memory.
Nope. Gotta be efficient. Always efficient. Look at all these apps we're deploying. This is gonna be the best node ever. I'm so excited for this node. Look at this. So pretty. I can't wait to see this node done. It's gonna be my favorite node ever.
Best one. Hey Zach, what's up, man? What are you guys doing? We're talking about container orchestration.
Yeah, we just deployed a node on the server. We just deployed a bunch of
I
apps.
really need, do you mind if I wait?
Well, actually-
Oh,
Now we have node failure. What are we gonna do?
I don't know. We actually,
That's right.
so let's see what happens.
Yeah, so let's go over to our other node. Look at that. Thanks to Kubernetes, we've taken all of our failed containers and now we migrated them over to this awesome second node. This is fantastic.
Magic.
I really hope that this helps explain how orchestration works. Thanks for watching, social media.
So, oops. The video itself obviously is meant to be funny. I have to restart my camera here. The video obviously is meant to be funny. In case it didn't come through in the webinar, I know that Dan, I think, might have placed a video or something. We'll make sure that the video itself is included at the end, so you can go watch it smoothly on your own. But again, it's supposed to kind of help explain from a very high level. So let's go ahead and dive into containers. One of the questions when I first started giving this session was, it's really great information. Love that you're passionate about Kubernetes and Helm and all these deployment tools. But what is a container? What is an image? Very simply put, containers is operating system virtualization. Traditional virtual machines was hardware virtualization. So when you think about the difference, you actually have the kind of the operating system itself. The containers are sitting on top of the kernel. Whereas with virtual machines, you have individual virtual machines and individual operating systems with apps sitting on top of that. So it's just another way to kind of take that box and make it faster and more portable. You can also get into Windows containers, where even if you went into Hyper-V, that's even additional isolation and additional performance. Hyper-V containers will actually isolate the kernel itself. Let's go next. Containers itself, very blunt, it's not an actual real thing. It's an application delivery mechanism with process isolation. And it's based on several Linux kernel features, actually. And so, again, my background coming from Linux and open source, really kind of seeing how even with Windows containers, it's playing off of these key features, right? You'll hear, especially in Kubernetes, you'll hear two different words probably. You'll end up hearing namespaces and you'll hear C groups. To, again, separate it and make it simple, namespaces is what a process can see. That's your PID, your mount, your network, your user, and your C group. But C groups themselves is what a process can use. That's the memory, the CPU, devices, etc. And then people asked, okay, it's great with Docker, or that's great with containers, but what is Docker? How does Docker play in? We're talking about Kubernetes. Why is Docker a part of this as well with your Docker image? Docker is an open source runtime. It has Mac, Windows, and Linux support. It is also a command line tool. They do also have a GUI as well for people who prefer clicky to typing command line. My hashtag is no clicky, so I use the command line. And then it actually uses what's called the Docker file format for building these container images. So it allows you to encapsulate your runtime environment in one file. And the Docker image format actually is a layered file system, which is really key. So here's a sample Docker file. It's the world's simplest. You have from, copy, and command. And then you use the Docker build command to build it. The -t would tag it or create a name for it. And the period at the end of that particular command is that it's assuming you're in the local directory where your file is. And then you would run it by simply saying Docker run and the name of what you called your image. And that's gonna run hello. But here's how that layer works. So you actually see individual image layers that are read-only, and they sit on top of a base image. In this case, we're doing Ubuntu 15.04. And then the top part, which is the random UUID, that's the actual container layer where read-write goes into that particular layer. And CodeFresh actually does something really unique with the way Docker layers for images are handled. Dan, do you want to talk on that?
Yes. So basically, the key element here is that when you're building a Docker image, it's made up of all these layers. And this is actually going to be really important when you're building your build server. So whatever it is that you're going to use to automatically build these images, you want to make sure that you can actually cache these layers and reuse them, because a lot of the changes that you make to an image happen at the top layer, because that's where your software is. But all of your dependencies and things, they're down on these lower layers. So you can actually get a ton of speed out of optimizing your build flow to take these layers into account, which is something that we've done at CodeFresh. That's like one of our core kind of optimizations that we do to make it so that our build times are really fast.
Yeah. And I love that part. It's really, again, like just the faster everything is, the faster the build can produce, and then you're able to move forward with your cycle. Remember the circle. So let's take another look at virtualization versus containerization. You kind of have two different types of virtualization. One uses a hypervisor sitting on top of a host operating system, sitting on top of hardware. The other is just a hypervisor on top of hardware. You can think of like VMware ESXi on type 1, and then let's say Hyper-V as part of Windows or Windows Server sitting on top of hardware as type 2. And then containerization is pretty much anything. You have the hardware, you have your host operating system, Docker engine sits on top of that, and then you have any of your dependencies sitting on top of the Docker engine, and your containers with any application dependencies sitting on top of that, completely encapsulated. Advantages of using containers. Remember, we talked about the pain points for both developers and IT and how they're different. Containers really addresses both of those issues. For developers, it addresses fast iteration, agile delivery, it's immutable, so it can work the same anyways. And for IT, it's efficient deployment and even elastic bursting, where you have to move from a private into a public cloud immediately based on demand. So we've talked about containers, we've talked about Docker images. We're going to dive right into container orchestration. Elements of orchestration are scheduling. You've heard Dan mention the word scheduler, which ties into Kubernetes. You have affinity and anti-affinity, health monitoring, failover, scaling, networking, service discovery, and even coordinated app upgrades. Using a container orchestrator gives you all of these benefits.
Yeah, and I'd add, if you're feeling like this is a lot of information, which it certainly is, and we will post it and we'll have the slides available, a lot of this is going to make sense as we demonstrate some of it live.
Yeah, there's a lot when I start going into the demo, and I used to do a lot more of a demo heavy, but the feedback I would get at the end is I still don't understand what Kubernetes is or how it works. It's so big, it has so much that ties into it, and I don't understand how Docker plays into it and these images and how are all these pieces actually fitting together. So I know this is a lot of information, but we kind of just have to go through it so that it makes the demo make more sense. So Kubernetes is the de facto orchestrator. It's portable, meaning it can run in public, private, hybrid, or multi-cloud environments. It's extensible, and most importantly, it's self-healing. So you have auto placement, auto restart, auto replication, auto scaling, just like what you saw in the video. Kubernetes as a whole empowers you to do more. You can deploy your applications quickly and predictably. You can scale your applications. You can roll out new features seamlessly. And you're able to also limit hardware usage to require resources only. So now let's dive even further into just Kubernetes. What is Kubernetes? Just like we define Docker, Kubernetes is an open source container orchestrator that automates deployment, scaling, and management of applications. It was originally created by Google, actually, and it was donated to the Cloud Native Foundation. Actually, as of I think just a few weeks ago, it was the first and as of right now, only project to have graduated from the Cloud Native Foundation. And you can go read actually about that on their blog. But features that it includes is automatic bin packing, which again, you heard it in the video, self-healing, horizontal scaling, that service discovery, load balancer. All of these features Kubernetes brings plays right into container orchestration and DevOps practices. We keep talking about how portable it is in Agile. Here's a visualization. You have your server sitting down at the bottom. You have a happy little developer IT person off to the left, and you have your container orchestrator right there in the middle in the blue. It's Agile. By having the container orchestrator, I can seamlessly move those apps over into the orchestrator space, and it's sitting on top of several servers. It's scalable. I can, with one command, add more workers or nodes to that server cluster, so that when I want to deploy more applications, I'm able to do so seamlessly. And the most important, as we demoed in the video, it's reliable. So in the event that we do have servers that go down, especially when you're using a managed Kubernetes service, it's self-healing. So it'll spin new servers up, and the apps that you deployed are still up as well. So if you want to go and play with Kubernetes and get started, you can actually go to Minikube, and you can go to GitHub and download Minikube. That's a local, doesn't require any kind of cloud. You can get started with it there. In the cloud, Azure has several different options. You can do ACS, AKS, which we're going to talk about today, and ACI, which is just an Azure container instance, but it's backed by Kubernetes. Amazon has their EKS, and Google, for their Google Cloud Platform, has GKE for Google Kubernetes Engine. So every major cloud provider has some access for Kubernetes. The ACS and AKS that Microsoft offers is our container service, but one is managed and one is unmanaged. And we'll talk about what that means. So with AKS, it is your Kubernetes cluster completely, and it's managed by Azure. It's managed by us. We really recommend and push AKS because it is the fastest path to Kubernetes on Azure, and you can get up and running with 3 simple commands. I like to argue it's technically 2 if you already have the local Kubernetes tool installed on your system. It's easy to manage, so you can do automated upgrades and patching. You can easily scale the cluster up and down, and it's still a self-healing control plane. It's also 100% upstream Kubernetes. When I said you can get started with 3 commands, I meant 3 commands. So getting started means that to create my cluster, I simply do an AZ for Azure CLI, AZ AKS create. I put my resource group name in and my cluster name. I can tell it to generate SSH keys if I want, or I can specify my own, and it'll go create the cluster. The second command for AZ AKS install CLI, that's actually optional. That's where it's going to download kubectl, kube control, everyone calls it different, to your local system. But if you already have that installed, you don't have to run that command again. The third command is actually what's going to create the link from your local system to your Kubernetes cluster in Azure. So the AZ AKS get credentials is going to take your context, your config file, and save that locally. And what's cool about this command is even if you have multiple clusters you want to manage, every time you run that command, it's just going to merge your clusters. It's not going to overwrite anything.
Yeah, and I would add that what you find, because there's some people in the chat talking about Minikube. Minikube is really great for learning the mechanics of the underlying kind of principles of Kubernetes. It doesn't quite replicate a real Kubernetes cluster. There are some nuances. And actually, in order to just get something up and running and start playing with it, I find that this is actually a lot easier. Having this just AZ, AKS, create, and you're basically off to the races. And even you'll install kube control for me, 3 commands to have a Kubernetes cluster up and running. I can play with it. I can try to deploy to it. Really, really great way to get up and running and get started and just see how easy it can be to start using Kubernetes. You don't have to understand all of the etcd underlying node architecture to actually get value out of it, which is true too of I mean, if you think about it, we all use, we all used VPSs back in the day. We've all used EC2 instances. Yep. We may not understand the underlying architecture of how people make that happen, but we can use it. And I think this is perfect for getting something that's managed and works.
And what's also really interesting is that command gives you 3 nodes. So rather than just having Minikube, which is local on one system, you actually get 3 servers, 3 workers that are going to automatically be spun up for you by default. You can easily, as we'll see on the next slide, add more agents or workers with the AZ AKS scale command. If I want to upgrade the version of Kubernetes I'm running, I simply use the upgrade command. I don't have to worry about upgrading any of the other pieces like Dan was saying with Minikube, or if I'm using, on the next slide, if I'm using ACS, which is Azure Container Service with Kubernetes, but it's unmanaged, it's not the AKS, I'm also in charge of, in addition to my agents and my workers, I'm in charge of the master VMs. I have to control the hardware and the canonical updates and the everything else that's a part of the control plane. Whereas with AKS, Microsoft, Azure, we take care of that for you. All you have to worry about is the agent pool itself. So it's just like Dan said, it's really powerful. It's the fastest way to get started. And now we'll dive in a little bit further into release automation tools. And I apologize, there's actually, I think, an icon that somehow missing on the right, but that's supposed to say Kashti. We are going to focus today specifically on Helm, which is the package manager for Kubernetes. Helm itself is the best way to find, share, and use software that is purposely built for Kubernetes. You can manage complexity, can very easily update and even roll back if you need to. It's very simple to share because you can take your Helm charts, they're called charts for your releases, and you can actually package them into tarballs. You can put them into your own Helm repository, which CodeFresh actually supports. You can add your own Helm repository to CodeFresh. And then you can, as I mentioned with rollback, you can roll back also to an older version of a release with Helm. And so Helm Charts as a whole allows you to define and install and upgrade even the most complex Kubernetes applications. So for some of the people in the chat that might already have some experience with Kubernetes, you know that you have to define your deployments and your services and your load balancers and your databases. And for really large and complex workloads, that can become very hard, very quick to manage. Having a Helm chart really allows you to kind of take all that and keep that organized, because it's essentially a template or a parameterized file where you're able to seamlessly deploy everything all at once. So we'll demo that today. Just a little bit more about how Helm works. It is a Kubernetes package manager. It combines multiple Kubernetes resources. I mentioned templates, and you can do things like easily upgrade. There's key concepts that I want to go over first so you can understand. Helm itself is a local client. It communicates to Tiller, which runs actually on your Kubernetes cluster. So Tiller, because you'll hear that word, is on Kubernetes, and Helm is the local tool. Helm is the CLI, essentially. And Tiller is, again, the in-service server that interacts with the Kubernetes API. Chart, as I mentioned, is the collection of resources. So this is the visualization I really wanted to show. You have Helm in the purple box right there, or pinkish. Helm install, upgrade, delete. That's the local commands that are going to be running. But it's talking to Kubernetes, where Tiller's listening, hands the request off to the Kube API server listening in Kubernetes, and then handles the release for your chart. And that includes services, your deployments, any config maps, pods, etc. It's really, really powerful. So now, if you want to get started with Helm, you can do helm.sh and go check it out. But we are ready for our demo. And I thank everyone for kind of bearing with me for the slides. I know it's a lot, but we want to make sure that all these pieces really make sense when we go right into it. So I have, first off, you can also completely recreate this demo on your own. I will have a blog post going live later today that'll actually explain kind of all these pieces, including my CodeFresh YAML. So you can copy and paste, get started with CodeFresh, and set this up in a matter of minutes, really, all on your own to learn. But you can go check out the repo that I'm doing for this demo. My GitHub and every major source of contacting is JL Dean, no relation to James Dean, so D-E-E-N, and then Croc-Hunter. This particular demo was originally written by Levi Evanson, who is actually part of the Deis Helm team at Microsoft. And he actually wrote it for Jenkins, and we made it work with CodeFresh. And I think it was actually it's a lot more seamless. So let's go ahead and take a look at how it's kind of working. I have the Croc-Hunter game right here at codefresh.k8s.az.jessicadean.com, and I'll explain that alias in my blog post. But it's a very simple game. I can see the host name, which is the pod that my application is running on. I can zoom in right here. I can see the release, which again, we talked about Helm Releases. I can even see the commit ID and any other information I defined. When I start, I can shoot lasers or fish, depending on what image the game is using.
This is a AAA game.
Oh yeah. It's we spare no expense here. But how this is working and how this is deployed actually is right down here in the workflow. That YAML that I mentioned I'm going to make available. This is really where CodeFresh kind of makes everything powerful. I have steps, and I'm able to build my Docker image in these steps. I can tag it based on a naming convention that makes sense for me. But you saw in my particular game, I have down here the commit ID. I'm actually getting that commit ID as part of my building image. So to do that as part of my build pipeline, I'm actually using a build argument that CodeFresh allows me to specify. So I can specify any defined build arguments and pass whatever variables I want, and CodeFresh will build it for me. What's also interesting is I have two different deploy steps because I have two different branches. I have a dev branch and I have a master branch. And for my master branch, I actually have it deploying my Helm chart. But in the dev branch, I want to make sure that my deployment is successful before it gets over into master. So again, using the same step convention, CodeFresh actually allows me to specify a dry run flag with Helm. So the same kind of commands I could run locally from my Helm client, CodeFresh allows me to specify as part of a pipeline. So this is all that deployment or infrastructure as code, and I can immediately build it. So for example, we built one right before we hopped on this call, and you can see this particular master build. This is the 9, we'll zoom in here real quick, 9.2 AED 9.6. If I zoom out, we see that is the same exact commit ID here. So CodeFresh is just building whatever is getting released. And we can see with the deploy step, we can actually see the commands that were run. We can see that it is running my Helm upgrade commands. It's installing the chart for me. It is cloning my repository. It's building my Docker image. And you'll notice here when Dan was talking about how CodeFresh caches the images or the layers of the image, it's already saying this layer exists, this layer exists. It's only pushing different layers that have changed. That's what sits on top. And now this looks like a lot. And this is in any CI/CD tool, this is the hardest part to explain because it's all command, it's all code, right? This is where CodeFresh really accelerates. They have direct Kubernetes integration where I can actually visually see my Kubernetes cluster from within their tool. I don't have to do a kubectl proxy command and open up the UI attached separately in different windows and move around. I can manage my CI, CD, build, release, Kubernetes, Helm, all from the same exact tool. So I can see that I created a namespace. We talked about namespaces. I created a namespace for my cluster, and I have a service running. I have 3 different replicas, which is what I define. And I'm using an image actually built in from CodeFresh. It looks like you guys give me a private repository.
Yep, yeah, CodeFresh has basically, you saw kind of in the pipeline, out-of-the-box steps for working with Kubernetes. And as I kind of mentioned at the beginning, we really wanted to take all of the components that you really have to have when you're doing DevOps with Kubernetes, and we wanted to build them in one place. And so we do have a built-in private Docker registry that's included for free. Of course, it doesn't stop you from integrating with any external. You can just basically 2-click add any other external registry.
I can add before, when Dan and I first started working together, we added an Azure for the registry. This Kubernetes cluster obviously is an Azure Kubernetes cluster, so an AKS cluster. I spun it up just yesterday, brand new for CodeFresh. And when you actually click even on status, here's the other insightful stuff. It'll actually give me my service status, my deployment status, my replica status, my pod status. So there's been times where I'm testing out a new image, a new build, and before I can even get the information from my command line, I can see that my build or my release failed because it's having an image pull error. I didn't create a secret with my credentials for that private repository in CodeFresh. And CodeFresh will tell me that before even my kube control will, because for that, it's kind of a manual process. I have to run a command to get that information. So again, it's really powerful there. I can also see that this was a Helm release. This was a chart that I deployed. And you'll see there's actually 2 revisions. If I click on it, I can see again the image that was used, any labels, and the status. I can even click on the history as far as if I upgraded it or just did the install.
Oh yeah, click on that arrow. It'll show you if nothing in your chart changed when you deployed this last time.
Exactly. I just spun up a release and it did the upgrade. I can also hit any of these buttons to roll back to the different versions of release. If I hit the chart button, I can see the files in my Helm chart. I get really granular information. I can see the values that were used. So I actually put as part of my deployment, I want the commit SHA, I want to know the image, I want to know the name of the pull secret, and I want to know the image tag. You'll also see that I am using an ingress controller. And so that's the host name that I've specified. So I'll explain this a little bit deeper in depth because it gets into some networking in my blog post later. But if you saw under Helm Releases, I have a few different charts. Croc Hunter is what I deployed, but I actually have Nginx that I also deployed through Helm. That's an Nginx ingress controller. And then I have kubelego, which is another Helm project. This is actually one that the Helm team manages, and I can quickly deploy and set up. So any deployment for a web application I push, even through CodeFresh, will actually be backed by my Nginx ingress controller, and kubelego will assign an SSL certificate to it, a self-signed one. So that's why when we go to this alias, we see that it is SSL backed. And all of these are using Helm Charts, and CodeFresh is able to seamlessly tie in to any of my releases. And again, I'll go in a little bit more in depth in the blog post how that's all configured, but it's all something that with AKS, CodeFresh, and a fork of this repo, anybody on this call can recreate. It's ridiculously powerful. One cool thing also, even taking the releases further, is the Helm charts that CodeFresh gives you right built in. You have Kube apps, which is how you can quickly go get started with Helm. They're managed, tried and true, stable releases of Helm charts by the Deis team. And there's tons of them. There's Artifactory by JFrog, there's WordPress, there's Jenkins. You can very quickly and easily go set up any one of these services and pods. But we also tie right into Azure. So you can actually even get started with some Azure charts for Azure Service Broker or Drupal. And whereas previously to get started, you might have to run a command, again, from CodeFresh, you can just simply click the install button. And the install button will allow you to select your Kubernetes cluster, select any namespaces you want to deploy, or create a new one. And then you can even specify any kind of values that you need to define. So anything that you would have to instinctively know from command line, CodeFresh really kind of walks you through this. It's probably one of the easiest ways, if not the easiest way I can think of, to get started with all of this.
Yeah, and going back a few months, as we kind of baked a lot of this into our platform, I remember it was almost 7 months ago, we were still talking about using Docker Swarm, and you came over to the office and we were talking about supporting Swarm, and I said, hey, you know what, let's try doing some Kubernetes stuff here. Yeah. And we sat down and it was like a week later, we were like, oh yeah, we're all like Kubernetes experts now. Yep. Because we've deployed it, we've played with it, we've got applications up and running, we've changed networking. Now we're starting to modify the configuration files, but it really is a great way of onboarding your team. And I mean, not to sell too hard, but talking to the team over at Giphy, they serve, I think, 2 or 3 billion GIFs a day, and they use their CodeFresh customer. And I was talking to them the other day. We're getting to a case study, but they basically said that when they wanted everyone to start using Kubernetes, their first step was to get everybody in a room, pull up CodeFresh, and have everybody just start using it. And that by doing that, they were able to get everybody migrated within a few hours.
Yeah, it's really powerful. And so I actually clicked into the account settings, by the way. When you set up your CodeFresh account, you can, under your name, hit on account settings and go to integration. And again, under integration, there's a Kubernetes option. There's even a Helm option. That's where you could add your own Helm repository. But this is how easy it is to really add your cluster in. And they have all major providers: Azure, Google, Amazon, a custom provider. That day that Dan talked about of let's just see if we can do this, we didn't have official Azure support, so I clicked custom provider, and this is truly how simple it is. This is the process you go through. You hit, and we'll zoom in here just a little, but you hit add cluster, and all you have to do is run. They actually have a blog post you run 3 different commands to get your host, your certificate, and token. They have a test button that'll help you test the information you provide, and you give it a name, whatever you want, and that's it. Your cluster's already added. So all the information I'm getting from this particular Kubernetes service dashboard, I got just from doing those 3 commands and adding my cluster in, which was funny because we had spent probably about 2 months, I think, to try to do different types of Docker Swarm support. And there was still, due to some SSH tunneling and redirects, there's still a lot of things that weren't perfect and definitely not easy. And Kubernetes, you just add it in, and it was just seamless.
Yeah, smooth. And so, and we're actually starting to get into the questions zone here. As I see a lot of people starting to ask questions in the Q&A. Feel free to keep pushing those in there, and we're gonna address all those. But I'll say on the Kubernetes side, one of the things I've seen a lot of people do who are in the cloud migration phase is they'll use CodeFresh to actually connect to their on-prem cluster, where maybe they've got an instance of of, I don't know, I want to say Tectonic or maybe OpenShift or something like that, they'll have those private Kubernetes clusters connected to CodeFresh through the agent, the CodeFresh agent, and CodeFresh can be deployed on-prem as well. And then they'll also connect to like an Azure cluster. And that gives them the flexibility to say, well, some of this stuff we can actually start moving onto the cloud, and we have comfort that we can do that. Or if they have a multi-cloud setup where they actually have a single Kubernetes cluster that's on on private and cloud, and they have failover between the two. This is their kind of more advanced but really fun use cases that we see people doing.
It's really just amazing just how powerful it is. And again, if I go back just to the repository while we start loading up some questions here, we can just see how simple and seamless that kind of build is. I mean, it took care of the building the image and doing my actual deployment all from CodeFresh. Everything's just all added in, including the ability, and I'll show that real quick.
And you've been doing this for a while. How's the reliability been?
It's more reliable than I think any other tool I've used, which is one of the reasons why I include it in every demo. I've demoed Jenkins, I've demoed Travis CI, VSTS. The support is there, but the unique thing about CodeFresh, again, is having that direct native integration, I think is really powerful. And the cool thing is again, with a lot of these tools, you can still use them in unison. I've used, and I know Dan has seen this demo, I've used CodeFresh to handle my build and validation right alongside the Jenkins and VSTS build too. It's not as though you have to choose one or the other. It really does play nicely together, but from a reliability standpoint, it's pretty much green light every time.
Yeah, great.
And this was the one part I did want to say is I'm even able to use my custom tags as part of my pipeline. So if I want to specify any kind of custom information, I can pass that right along, and CodeFresh supports that.
Great.
You want to go ahead and take a look at some of the questions?
Yeah, do you want to put up our
yes, our final slide.
So we're gonna move into the question and answer period of this. Great job, Jessica. That was a fantastic overview of DevOps and containers and Kubernetes and CI/CD pipelines, and really giving everybody kind of an overview of this whole space and things they should be thinking about. A lot of questions coming in, and we'll try to answer these as fast as we can. One of the questions is Azure Kubernetes Service, AKS. Is it now in general availability? Is it still in preview? What's the status there?
It is still in preview. I get asked quite a bit when it's going in GA. My official answer to that is Microsoft has two major events per year, really. We have Build and we have Connect. Build is coming up right at the beginning of May. It's May 7th through 9th in Seattle. And then Connect is usually around November. We have a tendency to make announcements around those times. So my official advice is while AKS is not GA today, stay tuned. That might change. But any information above that is above my head.
And I think there are people that are using it in production today.
There are. The biggest blocker right now from my relationship with the team is really deep networking and VLAN kind of scenarios. But I know that the team and the networking team is working hard on that every single day to work through some of those blockers. But I use AKS every single day. I think in some of the demos that Dan and I have partnered with in the past, it's always an AKS cluster. Mm-hmm. That's where Azure really kind of comes in. I see another question was, how does Azure play into this? We're using Kubernetes on Azure. That's really where Azure's piece is we have the Kubernetes service running over in my Azure subscription.
Yeah, good. So lots of questions. Gosh, I'm going to try to keep track of them here and have it be orderly. But one of the questions was, what's the pricing model for using Azure Kubernetes service? Is there a free tier or is there some sort of free trial people can use? You can go to Azure and you can actually get started today with a free month trial. I think it's like $200 in credits to kind of get started and get playing around. There is also some funding, I know, for open source projects and startups. Pricing is not my specific area of expertise, but if you do go over to Azure, I know they have a pricing page and they have different resources for different groups. But you definitely can, anybody can go get started today for free and we'll give you $200 worth of credits. That's the current price right now. Great. Another question was, can CodeFresh be deployed on-prem? The answer is yes. We have a couple of options. We do have the cloud version, which is what Jessica's using here. Our most popular option is called hybrid, where we actually place a CodeFresh agent on your infrastructure, and this keeps your source code, your builds, all those things stay on your infrastructure in your own Kubernetes cluster. Gives you access to your on-prem Git provider, your on-prem Kubernetes clusters, those kinds of things. And then we also have the option to deploy CodeFresh as a Helm chart, actually on your own cluster. Agent is much more popular because it's very, very fast to get running. The Helm chart is being used by mostly very large companies like HP are using it. And then another question was, can you add a custom provider like on-premise? And I think we kind of answered that.
Yeah, because it's if you're running CodeFresh again on-prem, then you can also use your on-prem Kubernetes cluster to communicate, I would assume, right, with that agent?
Yeah, okay. Another question coming in is Kubernetes mature enough to run stateful applications like databases, Mongo, Cassandra, etc.? What are your thoughts on that? I have some of my own thoughts.
I think so. Kubernetes itself, I feel like a lot of people ask that kind of question because it's still very new. People don't realize that it's only about 3 years, a little over 3 years old. But as we mentioned earlier, it's really kind of all major companies for container orchestration has kind of gone all in because it is, I would argue, it is production ready. That's one of the prerequisites, I believe, the Cloud Native Foundation has for a project to be able to graduate, is being used in production in a wide scenario. And what are your thoughts?
Yeah, well, and so here's an example, and this is kind of an anecdotal story, but I think it's effective. Last year at DockerCon, this was right before the election, the 2016 election. Everybody remembers very, very contentious and lots of stuff going on. And USA Today was over at DockerCon, and we were chatting with them, and they were saying, you know, we really love Kubernetes. We've decided to go all in. We've actually just switched everything over. And we said, oh, you mean you're trying it out for usatoday.com? And I think it was USA Today.
Okay.
Maybe it was someone else. I can't remember now. It was someone like them. And they said, yeah, we just switched everything over. And we said, it's 4 days before the election. And they said, yeah, it's running great. And it's scalable and it's reliable and it's awesome. And I was like, wow, they did this like 4 days before the election, running in production, being very effective. And actually, we see this across the board. I mean, GitHub.com is now 100% Kubernetes. So I think that Kubernetes is very much mature enough to run stateful applications. It's mature enough to run databases. And it really is, it just comes down to, hey, you've got a volume, you've got containers, the containers can come and go, the volume gets reattached to all of these, and you're off to the races. And it's pretty amazing because I think about how much work it was to build load balanced stateful applications 10 years ago.
Yeah.
And it was, it was a 6-month it was a huge engineering effort. And it's so much easier now with Kubernetes, with containers, with kind of this 12-factor app approach.
And isn't CodeFresh, correct me if I'm wrong, and I may be, so I apologize, but isn't CodeFresh also running on Kubernetes?
Yes, CodeFresh runs 100% on Kubernetes. Everything is on Kubernetes. And so it's kind of confusing sometimes when I talk about it, because I tell people CodeFresh is Kubernetes native, and I mean that means it makes it easier for you to deploy to Kubernetes, but also it runs on Kubernetes. So if you're looking just for scalable build architecture, CodeFresh is kind of natively built for that.
Yep.
Okay, so I'm switching. Somebody said audio wasn't working, but I wonder if it's just him. There was another question, which is, how does Helm help with CI/CD?
So I know that everyone also wants to grab this slide, but I'm going to minimize this slide real quick because I can actually kind of show. This is also going to be another talking slide that you can go connect with me at. But essentially what a Helm chart is I mentioned it's parameterized. This is, I'll zoom in here so you can kind of see, this is what a Helm chart looks like. So if you've ever done a deployment with Kubernetes on your own, you're having to define the services and the deployment, any persistent volume claims, any config maps. You're having to deploy all that manually. And you're having to keep track of all this information for the YAML file manually. One of the other things that we often joke is tabs are spaces.
Yeah.
And trying to deal with a YAML file where you have your tabs in space and something breaks. In fact, I've actually sent Dan an SOS before saying, my YAML file isn't working. He's like, did you fix your tabs or spaces? And Helm removes that issue. So you see this as parameterized. The only information that I have to fill out really is what's called my values file. With Helm, that's kind of the knobs and dials for how Helm works. So I fill this information in, and the Helm chart really takes that data and actually passes that right into the parameters. So, and you'll see actually in this particular chart, which is the chart I used for today's demo, I have different image names and image tags defined, but I can use CodeFresh to overwrite whatever I had in my values. Now, best practice would be to have everything written in values and in source control. But again, when it comes down to testing and unit tests and development environments, CodeFresh gives me really the flexibility to handle this accordingly. I can even set my ingress settings. I don't have to manage individual YAML files for my deployments. Helm takes that and simplifies it from that release standpoint.
Yeah, and to add on to that, and maybe we can show something here. Go back to the CodeFresh interface. Okay. Basically, Helm is a way of generating Kubernetes configuration files. At the end of the day, in its very simplest terms, that's what it does.
Yeah.
If you go over to the Helm releases, and we look at this release that you just did, this Croc Hunter one, the values that are getting passed are really important. And if you click on the values, this will show you the values that changed at runtime. So when we're building a change and deploying this image, we need to tell the Kubernetes configuration to use this new image that we just built, which is tagged master-92AED96, right? It's got the commit shell on it. So this value gets changed at runtime. So it's actually not in Git at this point. Now you could do that. That's a flow that you could totally do. It's supported. But if you look at the manifest, what this will show you is these are the files that were actually rendered and sent to Kubernetes. So if you click on that config, you'll see that it's now taken the values file that you had when you committed, it built that chart, and then at runtime it said, well, I need to replace these values, and then it rendered it into the manifest here. So you could take these and apply them to Kubernetes again manually and skip the entire Helm process, because this is the output of Helm.
Yeah. And you can actually, I could, I think we have a little bit of time. I was gonna say, I could go in here and do if I did a Helm LS, I can see the same release information that I get from, this is obviously from command line, but that I get from CodeFresh. And if I were to do a K, which is just an alias I have, get deployments, I can see the deployments. I can go in and edit the deployment just as I would any other deployment, and I can see exactly what CodeFresh deployed for me. So if I were to do K edit, let me make sure I spell that right, edit deploy Croc Hunter, and specify the namespace for CodeFresh, I'm going to be able to see that same information that I get from CodeFresh. And so this is just another way to kind of show how valuable CodeFresh is. The amount of commands that I had to go through just to get this information, CodeFresh is able to give me that right in my release information.
Yeah, thank you, Jessica. So we probably have time for maybe 2 or 3 more questions. One of the questions that I saw, and I thought this was an interesting one, many companies such as Netflix run their containers in VMs. What are the advantages or disadvantages of doing this? I would start off by saying, really everything that we're running is technically running in a VM.
Yep.
At the end of the day, what we're talking about is there's a server somewhere. Okay, spoiler alert, the cloud is just someone else's computer, but there's a server somewhere. It has a bunch of VMs on it, and those VMs are providing the nodes for the Kubernetes cluster, which is now scheduling and handling the pods. Now, you could just have a VM and just tell it to start a container by itself. I think the big advantage of using something like Kubernetes is it's going to handle failover for you. It's going to bring pods back when they die. And to give you an example of kind of this container first thinking, I know a number of companies who have Java containers, and they've actually disabled garbage collection. And the way that they handle garbage collection is they let the pod fill up and die, and then they just schedule a new one because it's actually faster and more memory efficient than doing garbage collection. So it's kind of, that's like an example of a way that Kubernetes really changes the way that we do all this stuff.
Yeah, actually, exactly what he's talking about. If I were to go into, from the command line and manually do this, go into any one of my pods and delete one pod, because I told my deployment to have 3 replicas, after I terminate one pod, it's actually going to start up another one. It's even if one fails or terminates, whether forced or by just dying, it's going to automatically rebuild it because the deployment is still live. And the deployment's backed by Helm and Kubernetes, which is, again, sitting on top of a virtual machine.
Yeah, this is kind of what your video was, right?
Yeah, that's the entire point of the video, which is why we kind of laugh at it.
Yeah. Okay, so another question here. Where can I get training or certification on this pipeline, Kubernetes, Helm, CodeFresh? That's a great question. We don't have a certification program today. It's on my list of my very long list of things that I'd like to do. But we do, of course, have a ton of resources on our blog. We have, another meetup that we're doing next week. There is a Kubernetes certification. Is there like an Azure Kubernetes certification or something like that?
There's an Azure Linux certification. So they partner actually. If you have the Azure Infrastructure 533 certification, it's the 70-533 test. And that's again for understanding Azure infrastructure. And then you also have your Linux certified systems engineer, I believe it is. If you have both of those, we will actually give you an Azure Linux certification as well. And I know there's a Kubernetes certification that plays into that even more. I'm sure well, I shouldn't say I'm sure. I would think that after AKS goes GA, that Microsoft might also introduce an AKS certification on that as well. But I don't know for sure. I can say that you can definitely, there's a ton of resources on Channel 9 to go get started with AKS. Some of my talks have been recorded talking about this. There will be a blog post that goes live later today, recapping all of this that we talked about. And then one more question I saw was, how can I integrate VS Code with CodeFresh? The quickest way to get started with CodeFresh is using GitHub, Bitbucket, or GitLab. And because VS Code integrates with any Git repository, it automatically will, as long as you open a folder that's a Git repository, you can integrate right in with CodeFresh, because CodeFresh is listening to your Git repo and you are editing the repo locally from within CodeFresh or from within VS Code. So when you make a change and you commit it and you push it, CodeFresh is automatically going to fire off and take that change, because CodeFresh is listening via webhook, I believe, right?
Yeah, that's right.
Yeah, so via webhook to the Git repository. So you can have seamless integration of all your tools.
Yeah, great answer. This question is, well, actually, let me just read it. This is a kind of a basic Kubernetes question. Mm-hmm. I have created a Kubernetes cluster using kubadmin and GCP and created a Docker image which runs a Django app, and then is image deployed using Helm. But the problem is I can access the app using node port, but I want to access the app using load balancer.
I can actually demo that real quick. Or
you basically just have to change the type to say load balancer.
Yeah, so there's a service type. And this will happen even if you aren't using Helm, but if you are, you can do cluster IP, you can do load balancer, or you can do node port. And that's really where your service is going to change the IP listening. So you would just change this to load balancer, where it's going to have an external IP address now available. And literally balancer, you would save it and then redeploy. And that's it.
Yeah, great.
So.
Okay, let's see. I think we'll take maybe one more question, and what did I do? I think we'll take one more question, and then we'll call it a day. And again, thanks everyone for showing up. And we will have the blog post up, I believe, within a few hours, and then we'll link to Jessica's post, and vice versa. So you'll be able to find it very easily, and we'll send a follow-up email. Of course, if you do want more, if you have more questions than the ones that, than the final question here that I'm going to answer, feel free to hit us up with a one-on-one. CodeFresh, we'll do a demo for you. We'll talk through your problems and see how it fits in for you. So final question is CodeFresh a manager for Kubernetes and Swarm clusters on any cloud provider, or does CodeFresh provide backend infrastructure?
That's a really good question.
That is a good question. Yeah. So really, CodeFresh is very agnostic about where your infrastructure lives.
Mm-hmm.
So CodeFresh itself, if you're using it as a cloud, we provide the infrastructure to build and run the pipelines. But if you, for your actual production stuff, we expect you to connect your own Kubernetes cluster or Swarm cluster, even ECS, you could do that if you wanted. And if you want to have the builds happen on your own infrastructure, then you can use our hybrid or on-prem model. So you can have CodeFresh on your own infrastructure. But really, it's actually kind of, the answer is kind of both, because by default, you get the builds that's happening on CodeFresh's infrastructure. You don't have to worry about it. And we manage scaling the build services. And so we can handle, you know, hundreds, thousands of simultaneous builds through the magic of Kubernetes, spoiler alert. But yeah, if you want to build on your own infrastructure, you can do that. And of course, for your production, for your environments, we recommend connecting a cluster from Microsoft or another provider.
Yeah, absolutely. And I know that here, thank you for everyone who kind of stuck around. I'm just going to show my final slide, mainly one, because my picture's adorable. Number two, it has some really important information. So again, that demo repo, which like I said, there will be the in-depth blog post in a few hours. You can go fork that repo today and kind of get started. GitHub, JL Dean, no relation to James Dean, Croc Hunter. Some of the apps that we showed you that CodeFresh already has built in, but if you want to go look on KubeApps page, hub.kubeapps.com. You can email me. You can connect with me on GitHub, Instagram. Spoiler, Instagram's really just going to be pictures of the gym, my dog, and my truck, but and sometimes code. But you can go do that. And then the blog, where my blog post is going to be live, is jessicadean.com. Also, I mentioned the league earlier. If you want to go see the league's website, where myself or any team member are going to be speaking at any given time, you can go to loecda.com, and that'll give you that information. You can also connect with any one of us there as well. So otherwise,
Great.
I think that's good.
Yeah, so there was a question about how to do a manual approval process using CodeFresh. And unfortunately, we are out of time and I can't answer it. But if you use that request a demo button, I would be happy to give a more in-depth answer to that question. So we're going to end it there. Thank you everybody for participating. Taryn White for doing all the back-end work to make this thing happen.
Yes.
Jessica for putting the fantastic presentation together. I think it went really well. I think everybody was really excited and we engaged and we had lots of good questions. So feel free to reach out on Twitter to either of us. Today was awesome. This is just JL Dean. And thank you very much. And everyone have a great day.
Thank you very much, guys.